Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss differential equations. In this chapter, we are going to discuss the concepts of exercise 9.5. In the previous class, we have discussed the concepts of exercise 9.4 and we have solved some questions in the exercise. I hope you have understood the concepts of exercise 9.4 and I hope you have learnt well the sums in the exercise. I have given some questions as homework. I hope you have completed the homework also. Have you not, my children? Right. Now come to the concepts of exercise 9.5. Are you ready to listen the class? Right. In this exercise, we are going to solve the differential equations, the homogeneous differential equations. Here in this exercise, we are going to solve homogeneous differential equations. Okay, my children, before going to discuss what is meant by a homogeneous differential equation, first let us discuss what is meant by a homogeneous function of degree n. Okay, my children, see the first point. Homogeneous function of degree n. A function f of x comma y. It is a function in the variables x and y. Okay, my children, understood this point. F of x comma y denotes a function in the variables x and y. Is said to be a homogeneous function of degree n if f of lambda x comma lambda y is equal to lambda power n into f of x comma y for any non-zero constant lambda. Okay, my children, understood this point. If the given function satisfies this condition, then the function is said to be a homogeneous function of degree n. To understand this concept well, let us take an example. See the example. Let f of x comma y is equal to y square plus 2xy. Okay, my children, this is a function in the variables x and y. We have denoted this function as f of x comma y. Okay, my children. Now we replace x by lambda x and we replace y by lambda y. That is, now we are finding f of lambda x comma lambda y. How do you find? We have to replace x by lambda x and we replace y by lambda y. So here, my children, y square is there, so lambda y whole square plus 2 into x is there, so we are writing lambda x into here y is there, we are writing lambda y. Understood this step, my children? By replacing x and y by lambda x and lambda y respectively, then we got this step. Okay, my children, understood this step? Right. Now let us simplify the terms. Lambda y whole square, by simplifying the term, what will you get? Lambda square y square. Understood this? Lambda square y square, my children? Right. Plus, by simplifying the second term, what will you get? 2 lambda square xy. Understood this? Second term, my children? 2 lambda square xy. Right. That is equal to, by taking the lambda square common factor from these two terms, what will you get? Lambda square into y square plus 2xy. Understood this step, my children? Right. That is equal to lambda square into, this function is nothing but f of x comma y. Yes or no, my children? Yes. So lambda square is equal to lambda square into f of x comma y. Understood this step, my children? So f of lambda x comma lambda y is equal to, we got here lambda square into f of x comma y. Okay, my children? In this stage, we have to focus on the exponent of lambda. What is exponent of lambda here? 2. So the function f of x comma y is said to be a homogeneous function of degree n based on the exponent of the lambda. We say that it is a homogeneous function of degree that number n. Okay, my children, 2. Understood this point, my children? Right. Now let us take an example, another example. Let f of x comma y is equal to sin x plus cos y. Okay, my children. This is also a function in the variables x and y. We have denoted this function as f of x comma y. Okay, my children. Now let us find f of lambda x comma lambda y. How do you find f of lambda x comma lambda y? By replacing x and y by lambda x and lambda y respectively. So sin x is there, so sin of lambda x plus cos y is there, cos of lambda y. Okay, my children, understood this step? Right. Here it is not possible to write. Can we write this function in the form of lambda power n into f of x comma y? No. So here f of lambda x comma lambda y cannot be written in the form of lambda power n into f of x comma y. We are unable to write this function in this form as we have done, as we have written the previous function like this. So it is not possible to write here. Therefore, the function f of x comma y is not said to be a homogeneous function. Understood this point, my children? Which function is said to be a homogeneous function of degree n, and which function is not said to be a homogeneous function? Understood this criteria, my children? We use this criteria, we use this procedure, we follow these steps to check whether the given function is a homogeneous function or not. Understood these steps, my children? Right. Now come to this example 3, my children. Let f of x comma y is equal to cos of y by x. Okay, my children. This is also a function in the variables x and y. We have denoted this function as f of x comma y. Okay, my children. Right. Now let us find f of lambda x comma lambda y. That is equal to cos of. How do you find lambda x, f of lambda x comma lambda y? We replace x by lambda x and y by lambda y. So here y is there, we write lambda y. Here x is there, we write lambda x. Understood this statement, children? Right. So here, after writing this lambda y and lambda x, we can simplify. We have to simplify. So lambda gets cancelled. Again, after simplification, what we get here? Cos of y by x. Yes or no, my children? Right. That is equal to, this can be written as lambda power 0. You know, any number to the power of 0 is equal to 1. So lambda power 0 into cos of y by x. So the function is written f of lambda x comma lambda y is equal to, we got lambda power 0 into f of x comma y. Yes or no, my children? Lambda power 0 into f of x comma y. We got like this. Okay, my children. So here f of x comma y is said to be a homogeneous function of degree 0. Understood this point, my children? Right. Note. Remember this point, my children. If f of lambda x comma lambda y is equal to f of x comma y, then the function f of x comma y is said to be homogeneous function of degree 0. Okay, my children, understood this point? Right. Now come to the point number 2, my children. Second point, homogeneous differential equation. In the first point, we have discussed homogeneous function of degree n. Okay, my children. Now we are going to discuss homogeneous differential equation. Right. A differential equation of the form dy by dx is equal to f of x comma y. Okay, my children, understood this point? It is said to be a homogeneous differential equation if f of x comma y is a homogeneous function of degree 0. Understood this point, my children? the differential equation is in this form, and here f of xy, this function should be a homogeneous function of degree 0. Then this differential equation is said to be a homogeneous differential equation. Okay, my children. So first of all, we have to check whether the given differential equation is a homogeneous differential equation or not. Means first of all, we have to check whether this function f of x y is a homogeneous function of degree 0 or not. Okay, my children. If this condition is satisfied, the given differential equation is said to be a homogeneous differential equation. Okay, my children, understood this point? Right. To solve a homogeneous differential equation of type dy by dx is equal to f of x comma y, that is equal to g of y by x. Here we have to write this function in the form of y by x, in terms of y by x. This function should be written in the terms of y by x. Every term should be in terms of y by x. Understood this point, my children? Let us consider this is equation 1. We make the substitution y is equal to vx. Remember these steps, my children, to solve a homogeneous differential equation. First of all, we have to write the given differential equation in this form. Dy by dx is equal to f of x comma y, a function in the variables x and y. In LHS, only dy by dx should be there. We have to convert the given differential equation into this form. Then we proceed. We follow these steps. Okay, my children. So we have to substitute y is equal to vx. Now differentiating with respect to x, we have to differentiate this equation with respect to x. So what is the differential operator? D by dx. So d by dx of y is equal to d by dx of vx. I wrote here the differential operator d by dx on both sides. Okay, my children, understood this step. This implies d by dx of y. How do you denote d by dx of y? Yes, dy by dx. Okay, my children, understood this dy by dx? Right, that is equal to, come to the RHS, d by dx of vx. So here we have to use UV rule, product rule. Okay, my children, here v is not a numerical coefficient. This is also a function in y and x. Okay, my children, that is why this is a function and this is also function. So we use a product rule. So first function into d by dx of second function plus second function into d by dx of first function. Do you remember this product rule, my children? Do you remember this UV rule? So by applying the UV rule, by applying the product rule, we got this step. Understood this step, my children? Right. This implies dy by dx is equal to v into d by dx of x. What is the value of d by dx of x? 1. Okay, my children, understood this one? Right. Plus x into d by dx of v. How do you denote this notation? S, dv by dx. Understood this step, my children? Because d by dx of x is equal to 1. Okay, my children, understood this step? This implies dy by dx is equal to v plus x into dv by dx. Okay, my children, this is considered as equation 3. Okay, my children. So, to solve a homogeneous differential equation, you have to remember this step, you have to remember this step, and you have to remember this step. You need not to do all these steps. Okay, my children, directly you take y is equal to vx. This implies directly you can write. Remember this step directly. You need not do all these steps. You need not write all these steps. Directly you can write dy by dx is equal to v plus x dv by dx. Okay, my children, remember this point. Understood this point, my children? Right. Substituting the value of dy by dx from the equation 3 in the equation 1, we get v plus x dv by dx is equal to g of v. Okay, my children? Right. This implies x dv by dx is equal to g of v minus v. Here we are transposing this term to RHS, then it becomes minus V. Okay, my children, understood this step, right? Now, by separating the variables, in this stage, we use the previous knowledge. We bring the previous knowledge, we bring back the previous knowledge into our mind. That is variable separable method. Hereafter, we use variable separable method. So, by separating the variables, we get dv by g of v minus v is equal to dx by x. We wrote the entire function in v into dv is equal to the entire function in x into dx. Understood this step, my children? Right. After separating the variables, we had to integrate. Do you remember the steps, my children? Variable separable method. Right. So integrating on both sides, we get integral dv by g of v minus v is equal to integral dx by x plus c. You know, at the last step, we write constant of integration. Let us consider this is equation 4. Equation 4 gives general solution, primitive, that is primitive of the differential equation 1 when we replace v by yx, y by x. So after finding the solution in LHS and RHS, after simplifying, after finding integral of this function and integral of this function, here we get answer in terms of v. So we have to replace v by y by x. Okay, my children. Then we get general solution of the given differential equation. Understood these steps, my children? Please remember these steps, my children, to solve a homogeneous differential equation. Okay, my children? Right. Note, you have to remember this point, my children. If the homogeneous differential equation is in the form of dx by dy, not dy by dx. Okay, my children, understood this point? Here dx by dy is equal to f of x comma y, where f of x comma y is a homogeneous function of degree 0. Then we make the substitution x by y is equal to v, that is equal to x is equal to vy. Okay, my children, in this case, we have to substitute x is equal to vy and we proceed further to find the general solution as discussed above by writing dx by dy is equal to f of x comma y, that is equal to h of x by y. Understood this point, my children? Sometimes we have to write the differential equation. The homogeneous differential equation will be in this form: dx by dy is equal to f of x comma y, not dy by dx is equal to f of x comma y. Sometimes the homogeneous differential equation will be in this form. In this case, we have to make the substitution x is equal to vy and we proceed. So if we x is equal to vy, if you make the substitution x is equal to vy, then remember this step, my children, dx by dy is equal to v plus y into dv by dy. We have to substitute these value and we proceed. Understood this point, my children? Right. Now come to the sums in the exercise 9.5, page number 406 in the textbook. I hope you have understood the concepts of this exercise. Okay, my children? Right. Now let us solve the sums in this exercise. Right. Come to the question number 1. Show that the differential equation is x square plus xy into dy is equal to x square plus y square into dx is a homogeneous differential equation and solve it. Understood this question, my children? In this question there are two parts. First part is we have to prove that this given differential equation is a homogeneous differential equation, and the second part is we have to solve it. Okay, my children, understood this one? Right. Come to the solution part. Let us write the given differential equation, that is x square plus xy into dy is equal to x square plus y square into dx. Okay, my children. So from this equation, let us write dy by dx. dy by dx. We are transposing this term to LHS. This then it becomes by dx. X square plus y square by, we are transposing this part. So x square by x square plus xy. Okay, my children, we wrote the given differential equation in the form of dy by dx is equal to f of x comma y, because this function is a function. It is a function in the variables x and y. Yes or no, my children? So it is a function in f of x comma y. So let us assume that let f of x comma y equal to x square plus y square by x square plus xy. Okay, my children, verifying to check f of x comma y is a homogeneous function. We are verifying that whether this function is a homogeneous function or not. How do you check? We have to replace x by lambda x, we have to replace y by lambda y. So f of lambda x comma lambda y is equal to lambda x whole square plus lambda y whole square whole divided by lambda x whole square plus lambda x into lambda y. Understood this step, is learned. We replaced x by lambda x, y by lambda y in this equation. Then we get this step. Understood this step, is learned. Right. Now let us simplify. What will you get here? Lambda square x square plus lambda square y square whole divided by lambda square x square plus, by simplifying these two, by multiplying these two, what will you get? Lambda square xy. Understood this step, my children? Right. Now let us take lambda square common in the numerator. What will you get? X square plus y square by, here also in the denominator, let us take lambda square common. Then what will you get? X square plus xy. Understood this step, my children? Right. Here lambda square gets cancelled. Then what will get? Finally x square plus y square by x square plus xy. This is nothing but f of x comma y. Yes or no, my children? X square plus y square by x square plus xy. This is equal to f of x comma y. So we got here f of lambda x comma lambda y is equal to f of x comma y. Then what can you say here? Therefore f of x comma y is a homogeneous function of degree. It is a homogeneous function of degree 0. Understood this point, my children? So we have verified that this function is a homogeneous function of degree 0. Then we say that this differential equation is a homogeneous differential equation. Yes or no, my children? Therefore, given differential equation, I wrote in short form differential equation. Therefore, given differential equation is a homogeneous differential equation. Okay, my children, understood this step? Since this given function is a homogeneous function of degree 0, we say that the given differential equation is a homogeneous differential equation. Understood this point, my children? Right. So the first part of the question is completed. Okay, my children? Right. Now the second part, we have to solve it. Okay, my children? Right. Now come to the second part of the question. Solving dy by dx is equal to x square plus y square by x square plus xy. Okay, my children. Right. Now let us assume that dy by dx is equal to x square plus y square by x square plus xy. Okay, my children. Right. Now let us substitute y is equal to vx. Okay, but because here y by x is there, so let us substitute. Let us substitute y is equal to vx in the equation 1. Okay, my children, if y is equal to vx, then previously I told you dy by dx is equal to x plus v into sorry v plus x into dy by dx. Okay, my children. So we have to substitute y is equal to vx and this equation in equation 1. In this equation 1, we are making the substitution y is equal to vx. Then dy by dx is equal to v plus x dv by dx. You have to remember these two equations. Okay, my children. In the equation 1, then what will you get? V plus x dv by dx is equal to x square plus vx whole square. Here y square is there, so y is equal to vx. We are substituting. Understood this point, my children? X square plus x into vx. Okay, my children, understood this step? Right. This implies v plus x dv by dx is equal to what we will get in RHS x square plus v square x square by x square plus v x square. Okay, my children, understood this RHS? Right. This implies v plus x dv by dx is equal to, by taking a common factor x square in the numerator, what will get? 1 plus v square by, in the denominator also, let us take x square common factor. Okay, my children? Right. So what we get? 1 plus v. Understood this RHS, my children? Right. Here we get we cancel x square. Then we get v plus x dv by dx is equal to 1 plus v square by 1 plus v. Understood this step, my children? After that we had to transpose v to RHS. This implies x dv by dx is equal to 1 plus v square by 1 plus v minus v. Okay, many children, we transposed plus v to RHS, then it becomes minus v. Understood this step, my children? Right. This implies x dv by dx is equal to, take LCM. Here LCM is 1 plus v. Here what will get? 1 plus v square minus v into 1 plus v. Understood this numerator, my children? Right. This implies x dv by dx is equal to, what will get in the numerator? 1 plus v square minus v square. Understood this step, my children? Right. By 1 plus v. V square minus v square gets cancelled. This implies x dv by dx is equal to, what do you get finally? 1 minus v by 1 plus v. Understood this step, my children? So we wrote the given differential equation dy by dx in this form. Vx into dv by dx is equal to 1 minus v by 1 plus v. After this step, we had to separate the variables. Separating the variables. Okay, my children? Hereafter, we use that knowledge of separating the variables. Okay, my children? Right. So, I wrote here the previous step again. So, x dv by dx is equal to 1 minus v by 1 plus v. Okay, my children? Now, let us take minus common in the numerator. Then what will get? X dv by dx is equal to minus v minus 1 by v plus 1. Okay, my children, I have taken minus from the two terms in the numerator. Then we get minus of v minus 1 by v plus 1. Now, separating the variables by separating the variables we have to transpose this part to this side, x by dx to that side. Then we get v plus 1 by v minus 1 dv is equal to minus dx by x. Understood this step, my children? We have transposed this part to this side and x by dx to RHS. Then we get this step. Okay, my children? Understood? Right. Now integrating on both sides. Integrating on both sides. Then we get integral v plus 1 by v minus 1 dv is equal to minus integral dx by x. Understood this step, my children? Right. If you observe this integral, it is a proper rational function, improper rational function, because degree of this is a polynomial in v, this is also a polynomial in v. Degree of this polynomial is 1, degree of this polynomial is also 1. So here let us split into two fractions by dividing v plus 1 by v minus 1. How many times? v minus 1. So what will get? So we can write this fraction as integral 1 plus 2 by v minus 1 whole dv is equal to minus log mod x. Understood this RHS, my children? Because integral 1 by x dx or integral dx by x is equal to log mod x. Understood this step, my children? Right. Now, let us integrate these two terms separately. This implies integral dv plus 2 into integral 1 by v minus 1 dv is equal to minus log mod x. Understood this LHS, my children? Here I am integrating these two terms separately. Then we got this step. Okay, my children? This implies integral dv. What will get? V plus 2 into, it is in the form of integral 1 by ax plus b log mod ax plus b log mod v minus 1 is equal to minus log mod x, because integral dx is equal to x and integral dx by ax plus b is equal to 1 by a log mod ax plus b. By using this formula, first we used this formula, for the second term we used this second formula. Okay, my children? Understood this step? Right. This implies, let us write this as a whole square. Yes or no, my children? So log mod or log v minus 1 whole square is equal to minus log mod x, because logarithmic property m log a is equal to log a to the power of m. By using this logarithmic property, I wrote this second term. Understood this second term, my children? Right. This implies here we can add log c. Okay, my children. So v plus log mod v minus 1 whole square is equal to minus log x plus log c. We can add any constant. Log c is also a constant. Okay, my children. Understood this one? Right. This implies v plus log v minus 1 whole square. This can be written as log c by x. Yes or no, my children? C by x. Because log a minus log b is equal to log a by b. Yes or no, my children? This where a is equal to c, b is equal to x. Yes or no, my children? Right. Again, let us move that side. V is equal to log cx c by x minus log v minus 1 whole square. Understood this step, my children? Right. This implies v is equal to, again we use log a minus log b formula. Then what will you get? C by x into v minus 1 whole square. Log a by b. Log a minus log b. Log a by b. Okay, my children, because log a minus log b is equal to log a by b. By using this logarithmic property, we wrote these two terms as log of a by b. Understood this point, my children? Understood this step? So, after that, we have to substitute v is equal to y by x. Okay, my children? We have to substitute v is equal to y by x. This implies y by x is equal to log c by x into y by x minus 1 whole square. Understood this step limit, my children? Because v is equal to y by x. Okay, my children? Understood this step? Finally, we are writing the given the value v in terms of y by x. Okay, my children? Right. From question number 1 to 9, we follow the same steps. We follow the same procedure except question number 10. Except question number 10. The question number 10, the differential equation should be written in the form of dx by dy is equal to f of x comma y. Only the difference, only small difference. Up to question number 9, we write the differential equations in the form of dy by dx is equal to f of x comma y, and we proceed. Whereas for the question number 10, we write dx by dy, not dy by dx. Remember this point, my children. Dx by dy is equal to f of x comma y, and we make substitution x is equal to vy. Okay, my children, and we follow the steps. We proceed to find the solution of the differential equation. Okay, my children, will you try the remaining questions yourself? Please try yourself the remaining questions. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right.